This is a structure of MOSFET. To make this structure, we should insert source and drain at the substrate, and also we should stack up the gate dielectric and gate over the channel. The process making this structure is called photolithography. This is a general photolithography process. The first step, clean the wafer. We should clean the wafer before we start this process to protect the mispatterning by the contamination like residue. And skip the secondary, and the next one, coat with photoresist. We use the spin coating technique at this step, and then we softly bake the photoresist because it's liquid. So to stack up other materials over the photoresist, we should softly bake the photoresist. Next, align the mask. We must align the mask sophisticatedly using the alignment key. If we not, we are gonna stack up the materials at the wrong place. Next, expose the pattern. In this step, there are two cases can be happened, and it'll be determined by the characteristic of the PR used at the former step. If the PR is negative photoresist, the exposed light will make the bonding of the photoresist stronger than before, and oppositely, if the used PR is positive photoresist, the exposed light will make the bonding weaker. Then develop the photoresist with the developer. In this step, if we used the negative photoresist at the former step, the developer will get rid of the photoresist which is not exposed by the light. Or if we use the positive photoresist at the former steps, the developer will get rid of the light exposed photoresist. Also, the developer is liquid, so at the next step, hard bake, we should hardly bake the structure to dry the liquid developer, and also to make the photoresist hard, that we could use the photoresist as a mask. And the last one, remove the photoresist. We call this step strip because we strip the photoresist at the top of the structure. This is the photo of the process which I just explained. The first one is the initial state, and the next one, we coated the structure with the positive photoresist, and the next step, we put the mask over the structure and expose the light, and also we develop this structure so we can get this structure. And then we etch the silicon dioxide part, except the masked part with the photoresist, and finally we strip the photoresist over the structure. To complete the photolithography process, we should expose the light on the structure, and these three are the light exposing techniques. The first one, contact printing. Using this technique, we expose the light after we contact the mask on the photoresist. If we use this technique, there are many disadvantages. First, we contact the mask with the photoresist, so the mask and the wafer will be damaged either, and so it makes the mask lifetime shorter. And also, we just contact the mask and the wafer, so the mask pattern size should be same as the wafer. And the next one is proximity printing. Using this technique, we expose the light after we locate the mask above the photoresist. It makes less damage than the contact printing, but it also needs the photo pattern size same as the wafer. And also, because of the diffraction, the image will be poorer than before. So the last one is one of the solution of these two other techniques, the projection printing. We focus the exposed light at the mask over here, and for the next step, we concentrate the pattern light at the wafer again. So we have two different focusing steps in just one technique. Using this technique, we could make the mask pattern size much smaller than the wafer size. But if we use this technique, we have to use the stepper, and also there are two different optical steps over here. So yeah, optics are really complicated, and finally, it's really expensive. This is a structure of the stepper. We use this device for the projection printing technique. Using this device, we can make the mask size very small. But also that the mask size is small, we cannot print the total mask, total pattern on the wafer at once. We should print the mask pattern one by one at the die of the wafer. So and also there are two optics in this device, so while we use this device, the diffraction and refraction can happen easily. So to protect these kind of issues, we use the scanner. This is the scanner. We use it with the stepper to print the mask pattern at the die of the wafer one by one. There are slits at the middle of the scanner, which the exposed light only can pass through. So this technique will make the diffraction and refraction issue less than before.